Hello everyone, and thank you very much for joining me again in this live session, lesson number 42 already from the Java Fundamental stream, and we are discussing collections, we are discussing collectors actually. In the past couple of lessons we have started with Streams API, and you have seen how to create the stream source. You have seen how to use map and flat map. We have discussed about primitive streams, the in-stream, long stream and double stream, and we have actually also worked on examples with some of the basics, intermediary and terminal operations, if I correctly remember. And here we are now with a very large subject that is also part of the Stream API and introduced in Java 8 is the collectors API, and we're gonna discuss today at least a part of it. I'm not sure exactly if we'll be able to finish everything because the collectors API is pretty big. It's such a big subject, and syntaxes with collectors can become very complicated. I will try to lead them up to the complexity. You will find them in the OCP 11 exam questions, but I do recommend you do not use in real world scenarios syntaxes that are too complicated, and generally the ones you find in the OCP 11 certification exam, they tend to be a little bit more complicated than you usually would have to work with in real world applications. And I don't say that you shouldn't do whatever algorithms you need to do in your real world scenarios, but the problem is that if you complicate the code, you use the Streams API together with collectors, and you are downstreaming too much, like you will see we'll be doing in today's lesson. If you do that, then it's contrary to the reason for why Streams API and collectors together with them were introduced in Java 8. And remember, the reason wasn't that okay, starting now we are just adding some functional way of working in Java. We won't transform actually Java into a functional programming language. It's still object oriented, and if you need a functional programming language, you have Scala out there, for example, if you need such a language over the JVM. But the reason for why Streams API was introduced, as I've already told you in the previous couple of lessons, is to make some syntaxes simpler, easier to read. And if you, by contrary, write too complicated code, and instead of making it easier to read, you make it more complicated, then it's against the purpose for why Streams API was introduced. So generally, I would advise you to use simple syntaxes in real-world scenarios, and generally avoid using complex solutions, but do study complex solutions because they open your mind, and of course they will help you in case you want to obtain the OCP certification. So before going to the OCP certification exam, make sure you know and you understand also some over intermediate solutions. So that's why today we'll discuss also some more complicated way of writing things with collectors, not necessarily only the simplest approaches. But let's start with the simplest, and let's complicate the solutions up to one above, let's say intermediate, those that are the level of the OCP 11 exam. I will actually create a new package, examples here. And let's start with the first example to discuss the collectors in general, and then the toList collector, the toSet collector, the toCollection, and then the toMap as well. So we have 4 collectors for beginning, all related to collections and to collecting elements from the stream into a collection. And that's what we start with in the beginning, and then we discuss some more other collectors like joining, mapping, and so on. So example 1, and in example 1, of course, the main method, to make it simple, we'll actually use a list of strings, and I guess the list of strings should be enough for most of our examples. So let's just add some arbitrary strings here, preferably of different lengths, because we might want to refer to lengths in some of the examples. We can also repeat some lengths, doesn't really matter. Okay, and that's it. And now again, let's start with the collectors. So we get a stream out of the list, and you know already that you can do that by using the stream method, and then you can apply whatever intermediary operations you want here. So I will just state here that you might have as many intermediary operations as you want, but at some point you reach the end of the stream and you need to add a terminal operation, and the terminal operation we discussed today is the collect operation, which is a terminal operation receiving as a parameter a collector. So the collect is a terminal operation, the parameter, which is the collector, is the object telling the method how to collect the values. So the collect logic, the collect method will actually apply precisely the logic you have specified. Now, you don't generally implement your own collectors, but you use some collectors already implemented, which you create by the means of the static methods you find in the collectors class. So again, this is one of those situations in which you have a singular and a plural word, and I've told you already about these situations you find in the OCP 11 exam. Mind that this is collectors, and when it's collectors with an S, so the plural, usually it refers to a class, and usually it refers to an utilitary class. It's the same like you have with collections, the same you have with arrays, the same you have with executors. We didn't discuss about executors yet, but we will discuss about it in one of the future lessons. So now I shall decide which is my plan. What should I do with the values here? Let's assume I want to collect them in a list. So to do that, I only call collectors to list, and this method returns a collector knowing, whose implementation knows to take all the elements, put them in a list, and return them. And that's basically what the collect method does when I do something like this. That's why now I can take all the strings that are the elements from my stream and get them in my result list here. So whatever reaches the collect will then be collected into a list, and then I can use the list however I want. And you have seen this at the end of the previous stream, but I repeat it to make sure that I take the subject from the beginning, and you don't have to go to, if you now see this lesson for the first time, you don't have to go back and see the example. And I will do precisely the same thing, and I will show you that by using collectors to set, you can actually collect them, of course, in a set. So then you can have this result too, which is a set implementation, and you actually do the same thing when the elements reach the terminal operation, which is the collect here. Of course, in specific cases they might be not the same. Like in my case here, they are the same that left the stream because I have no intermediary operation. But of course, you can do whatever here, mappings, filterings, and so on, as we discussed in the previous lesson. And then what elements arrive at the collect terminal operation, they are then collected according to the rule implemented by the correct collector. First case, they are all put in a set and returned, in a list and returned. Second case, they are all added to a set and then again returned. So that's why in the first case, the type of the variable where I have where I've got the returned value of my stream is a list, and then in the second case, because I use a collector that returns a set, then I need to, of course, take these values into a set. Let's do the same thing now, but choose the collection we want to use. In this case, as you can see, we don't have the opportunity to specify which is the kind of list or which is the kind of set we would like to use. So assume we don't want to have any kind of set. We want to have a sorted set, for example. You know that sets generally we refer them as being unordered and unindexed collections. But in some situations we would like to use an implementation of a set that orders the elements or sorts them. And for example, if I would like to have the elements sorted somehow, probably I would choose to use a tree set, as we have discussed in one of our previous lessons. So can I do something like this? Can I actually specify somehow that I don't want any kind of set, I want a sorted set, like a specific implementation, like a tree set? The answer is, of course, yes, you can do that. Generally, it's not recommended to work with implementations, but of course there are situations in real world scenarios where you do have to use a specific implementation. So then, for example, if what you need is precisely a tree set, and you really want to get a tree set out of your stream, then instead of using a toList or toSet, which doesn't guarantee you the exact implementation of collection you will receive, it only guarantees the toList, it only guarantees you that you will get a list. The toSet, it guarantees you will get a set in the end. But if you want a tree set or a linked hash set or some other kind of collection, specific collection, then you will use the toCollection method. And then when you use the toCollection method, as the parameter of the toCollection method, you also have to specify a supplier. Remember, the supplier is that functional interface we discussed a few lessons ago from the Java util function package that doesn't take parameters, but it returns a value. The value this supplier returns is precisely the instance of the collection the collector needs to use in order to group the elements. I get to the map right now, so I'm just discussing first about these three, and then I'm going to maps. I will take all of them one by one, so no worries, I will get to all of them. Thank you for the question, by the way. So toCollection, again, I will finish with this just by deciding that I need a tree set here, sorry, and like this you have specified, yes, this is the collection I need to use. By the way, remember, when you have in a lambda expression, when you have on the left side and on the right side the same parameters in the same order, of course in our case here none, then you can anytime change it to the method reference. So that's why in plenty of situations you won't see the supplier provided this way, but you will rather see it like directly tree set new, which is using a shorter syntax, the syntax of the reference method. So yeah, and this way we can put it like this. So this toCollection will return us precisely, and this is compiling now, and it returns precisely the kind of implementation I ask for it here. So we can use, again, to recap, we can use toList to just get a list, we can use toSet to just get a set, or if you want a specific implementation of list or of set, then you have to provide the implementation, the precise implementation using the toCollection, and then you get the precise implementation. You want a linked list, you get a linked list. You want a tree set, you get a tree set. So you decide which is the implementation. Here you don't decide, here you decide which is the implementation. Now, getting to your question, because that was obviously the next collection I wanted to discuss is the map. So let's see what happens when we want to collect the values from a stream into a map. But for this I will create a new example, and example 2 will be my second example with the map. I still keep the same list of strings to be the source of my stream, so I need the elements. I have some nice strings elements and I want to change them to a map. When I want to change them to a map, I have a different situations than for a list or for a set, so for a general normal collection, single element collection, single element type collection, let's call it, because in case of maps are not any kind of collection. They are a collection of pairs, a key pair, key value pair collection. So that's why we need to specify in this case who is the key, which is the key and which is the value. And you need to do that, because if you don't specify that, then of course the stream, the collector can't know from just telling it this will be a map, who will be the key and who will be the value. And moreover, you have to take care that yourself that the keys are unique, because if you don't care of that, then you will get into situations where you will get exceptions, and that's precisely what I want to show you in this example too. So let's start with the simplest one. I want a map where the key is the string and the value is, for example, the length. It can be the same string, but I will simply choose to take a different value. So I will have the key as being the string itself, and the value in the map will be the length of the string. So in this case, it should be a map of string and integer, because of course we have strings as elements and the length of the strings will be integers. So this is my first map, and then I take the stream out from the list, and then I do a collectors, and of course there is a toMap there for that. So you will use toMap when you want to use to collect the elements into a map. And you have three kinds of collectors with the toMap. One of them is the simplest, is the one in which you only specify two functions, one that takes care of telling who the key is, and the second one that you can use to specify who is the value. So then you would use toMap, and you would say, yes, my key is itself, which means the key is the element itself, and then the other function is, and the value is length. Or maybe I put it there key and k and v, like key and value, but maybe it's not the greatest my greatest choice, because it might be confusing for you. You might think, oh, wait a little bit, why do I have a k and a v? They actually represent the same thing, so both of them are the string. So maybe it was better to actually choose an s, so that you can see s and here they represent the same thing, and that is each value from the list, which of course became the values in my stream here. So in my case here, I take the values and I say the string itself becomes the key, the string's length becomes the value. And if you print out this map now, you will see that of course I have the A, and then a 3 assigned to it, then you have B and then 1 assigned to it, and then you have C, and then a 5 assigned to it, and so on and so forth. So yeah, this is it. So you have the length for each string. The string became the key, the length became the value. Pretty easy. Now we have the situation in which you have duplicates. What happens if you have key duplicates? Well, we have a solution for that as well, but again, to keep all the examples easier for you to find in my GitHub afterwards, I will just copy this example and I will slightly change it by adding another AAA here. So guess what happens now, because I have duplicates in my stream, it's clearly now that I will have 2 times the AAA, and I try to use the string itself as the key. But the key of a map cannot be a duplicate. In this situation, you will receive an exception telling you that you cannot have duplicate keys in a map. So the collector doesn't know what to do, and instead of collecting your values, will throw an exception telling you, well, I have 2 keys here and I don't know what to do in this case, so I will simply throw an exception. So let's try it. I didn't change anything in the code, you have seen, so this is the same code from the second example. The only thing I've changed here is adding the duplicate AAA, and because of this, you see I get an exception which tells me pretty nicely here, yeah, you have a duplicate key, so I don't know how to actually create your map. In this case, you can get over it by adding a third parameter to your toMap, which is an operator telling what should happen in this case with the values. So for example, I can choose to simply sum up the values because I have some lengths here, correct? So instead of having the key AAA twice, because that's not possible, I will keep the key and I will sum the length. So I should see 6 instead of 3. I should keep a 6 here. So that's how it happens. It's the third parameter of this map has the values which represent the values of the duplicates, and then you use this binary operator to tell the map what should happen. For example, please sum up the values. When you have keys duplicated, keep one key and all the values will be summed up. Yes, you can decide whatever else you want to do. You can concatenate them, you can multiply them, you can put them in a list. You decide whatever you do, but in this case you have to add this nice operator here, this nice by function here. It's actually a by function to tell your map how to act in this situation, to tell your collector what should be the behavior when you have duplicates. And then instead of throwing an exception like it did in the first case here, because it found a duplicate, it will see this operation and will apply that operation for my duplicate. So I now run again the code, and you will see indeed that for the duplicate it simply applies this by function here, and that is why you see now you have no longer an exception. A appears once because anyway the key cannot be duplicated in a map, and the value became 6 because it's 3 plus 3, because that's the rule I have implemented here. That's what I've told the map collector to do. I told him please sum up the values when you receive duplicates, just sum them up. So that's one thing you could do in this case to eliminate this situation. And you actually have even a third implementation of the map collector, and I will again copy paste the third example, and I will create the fourth example by that. And the third option you have for map is to use the function with 4 parameters, and the fourth parameter is actually the supplier, which is telling the map in which kind of a map you would like to add the values. Like in the case of the collection, where you had to specify, for example, I want a tree set or I want a linked list, please give me a specific kind of collection. You can do the same thing here with the map, and you will have to specify this fourth parameter and telling precisely what type of collection you want. So for example, I want a tree map, so I don't want any kind of implementation. I want a tree map, and then I will actually receive a tree map. But don't forget a very important thing. If you use tree set or tree map, then your key needs to be comparable, or you should provide as well a comparator here, as we discussed in one of our previous lessons. Otherwise you will have a collection not from the stream itself, not from the collector, but you will have a problem with the map trying to sort your elements, and if the elements are not comparable and you didn't provide a comparator, then as you probably know already, this will lead you to an exception telling you that the elements cannot be compared and though they cannot be sorted. And this is how you create a map out of it. Now, what other kind of collectors do we have? What other choices do we have with streams? Well, we also have the possibility, of course, to join the elements. This is a really nice one, and it also suffered modification, actually an addition of an overloaded method in Java 9, if I remember correctly. And yeah, let's actually copy paste the previous example. I have example 5 here, and in the example 5 I will show you how to use the collectors joining collector, and the collectors joining collector will apply a concatenation to join all the elements. So in my case the final result should be a string, and then I use collectors joining. You can use the collectors joining, that's the first result here, without any parameter. And then if you use it without any parameter, you will simply get the values concatenated. So all the values that got out from the stream in my case and entered the collect will be concatenated, resulting in only one string here that I can print out. And then you have the second option where you can also specify a separator. And then we have the third option that appeared with Java 9, if I remember correctly, where you also can provide a prefix and a suffix to your string. So I can copy paste this, and if I want to specify I want them separated by a comma, I simply provide this as a parameter here, and in this case the second result printed out will be my values separated with a comma. So that's what should happen. So you see the first one didn't have any separator, the second one has a comma as a separator, and then the third one, the third result here, we can use the result that also takes a prefix and a suffix. And the first one is the delimiter here, it remains the same, but then the additional parameters is what will be before and after. You can put an A and a B, and then you will see A. Oh, if I put an A and a B, it will be difficult to read. So let's use some actually some brackets instead. So you will see the brackets will be surrounding my result here. So let's run this again and see that for the third result you will also have the brackets. And again, this collector joining with 3 parameters here, if I remember correctly, it's from Java 9. So you might, if you try to use it with Java 8, you will not be able to use it. So you see here the results for my joining collector. Pretty easy, isn't it? So collectors are not that difficult as long as you don't get to downstream. So one of our future things in these lessons, future examples, is to use it with downstreams, and then you will see actually that you can complicate a little bit the things. But let's take them one by one. So example 6. In example 6 I will show you an collector that appeared in Java 10. I think actually it's is the most recent of them, 10 or 11. I hope not to be mistaken. And it's called teeing. So what's actually teeing? It actually allows you to use 2 collectors at once. So for example, I would like to say something stream, and then I say collect, and I use this collector teeing. And when I use the collector teeing, I have to provide 3 parameters. One of them is the first collector I merge. The second one is the second collector I merge. So I merge 2 collectors, one with the other. And then the third one is actually what I do with the results from the 2 collectors. So for example, I say collector, let's say counting. I didn't show you what counting does, but I guess it's easy to imagine. It's actually counting the elements. It's basically counting them and nothing more than this. And then you have, for example, collectors joining, and then you will say with the result from A and the result from B, I do something. So then I do return, let's say, a list containing A and B. So I can do something like this. Okay, if you don't like the fact that I have used the return and the curly braces, you can actually do like this to simplify. So then I can take my result here, which will be a list, and the list, of course, in this case will be counting actually returns a long, and joining would return a string. And then I take the long and I take the string, and I get a list with a long and a string. It's just an example. You could actually put them in a map if you want, or you can do whatever you think you need to do with them, like concatenating into a string. I don't know, it depends on your application, but the idea is what teeing does is allow me combine 2 collectors. So you have seen how I have used to list, to set, to collection, to map, joining. And now what happens if I want to actually combine 2 of them? Well, I can do that with teeing. I can combine and run counting and joining at the same time on the stream, and then do whatever I want with the values here. This is the value from the counting, this is the value from the joining. And then in my case, I decided to return them as a list. So if I print it in the console, then you will actually see the list here. So nothing special. So I run it, and you see 6 is the number of 1, 2, 3, 4, 5, 6, and then the second one is the joining. They're joining there. So that's what we are doing with teeing. Simple streams up to now. Let's go to some more complicated examples, and let's discuss how mapping works. So the next one is mapping. That's one where you should be very careful. I've seen a lot of people confusing mapping with to map. So there are two different collectors. They do two different things, as you will see. You have already seen what to map does. Mapping is different. Mapping is actually representing the map functionality we have discussed in one of our previous lessons on streams. So you remember, a map actually gets a function and transforms a value to another value. So that's what mapping does. So whether to map is only a collector getting all the values and putting them to a map, as you have already seen, mapping is different. Mapping allows you to transform a value from a value to another. Like in case of our strings, we can take a very simple example and change the string to its length, for example. So you can change the string to its length. That's a transformation. So that kind of transformations is what you basically do with mapping. So in my case here, for example, I can decide to use list stream, and then I collect, and instead of collecting with a simple collector, I will use mapping. So mapping actually gets two parameters, and one of the parameter tells you which is the mapping, which is a transformation to the value. So in my case, as I said, I will transform the string to its length. You need a transformation. And then the second parameter is what happens to the values after they are mapped. So what happens after they are transformed from string to integer? What do you do with them? And then I have to get another collector and instruct the collect operation what should it do with the values after they are mapped. So I use mapping here, and I say my strings will become their lengths. And then after they were mapped from string to length, I will use collectors to list, to put them all in a list, for example, or whatever you would like to do with them afterwards. So this is the first collector here is just changing from string to an int. So for each of the strings you change their lengths, and then this is the second one, the second collector here, the one that tells what happens with the values after the first one applies. This is called downstreaming. So you can downstream them. You can specify another collector to be used on those values after the first operation has been applied. So in this case, I will get a list of integers as a result, because what happens here is that my strings will be mapped to their lengths. So from this first mapping, I will get a stream of integers, each integer being the length of one of the strings, and then all of the integers will be downstreamed with this collector that tells that all the values should be put into a list. So if I print my list now, you will actually see the lengths for each of the string into a list. And as a downstream, you can choose whatever other collector you would like to have here. You can even choose mapping again. So you can actually map them to something and then map them to something, and then you need another downstream, and you can go that infinitely deep. That's why collectors basically provide you an infinite way of manipulating the values from the stream. So you can do whatever you want. There is nothing else you can stop using collectors at some point. But again, I remind you what I've said at the beginning of this lesson. Don't forget that for certification exam questions, you need to understand up to intermediary and above intermediary complex syntaxes. For the real world scenarios, don't complicate the things too much, because the purpose of Stream API in Java is to simplify the reading of specific algorithms. If you actually use them and write to complex syntaxes, they are against their purpose. And that happens a lot with people when I've seen that with a lot of developers. Once they understand how Streams API works and how collectors work, then they tend to actually use them. They abuse of this functionality because, yeah, that's cool, now I understand it, so why shouldn't I use it and make it as complicated as possible? But that shouldn't be the way you think about it. Just keep it as simple as possible, at least for the real world scenarios. So don't fall the trap where you get to understand them and then you simply just push very complex syntaxes into your real world scenario, because the purpose again is to make your code easier to read, not more complicated to read. And the idea is that everyone should be able to read it, no matter of their experience. Remember what I've told you about streams a couple of lessons ago, when you read a stream, you read it like you simply need to read the words and you read it like poetry. You don't have to understand ifs, fors, else's, whiles, and so on. You don't have to get into the algorithm, because you simply read it. So as long as you can read the stream, that's a nicely maintainable, cleanly written stream. Once you can't read it anymore, then it's a problem. It will start to be a hard to maintain code, and that's something you would like to avoid in your applications. Okay, so now let's go to a much more difficult example. So let's complicate the examples one by one. So we discussed about mapping. I can show you the filtering as well, and then we have to discuss the partitioning by and the grouping by, which are again really important, and you will find plenty of them in the OCP 11 exam. So example 8, collect, and let's use some filtering here. Let's assume we'd like to filter the values. I can use a mapping to collectors mapping here, and again change it to the length of the string. And then once I've changed it to the length of the string, the next thing I'd do is to downstream it to say collectors filtering. Okay, and we have this filtering, which again is very similar to mapping. That's why I've chosen it here. The mapping receives the function you would like to use to map the values, and then a downstream. In my case, the downstream will be filtering, and then filtering receives also two parameters representing mostly the same thing as for mapping. The first one is a predicate, telling, as in case of the filter method on the stream, which are the values, how the values are filtered. So the ones that respect the predicate will appear further in the stream. Those that don't respect the predicate will be dropped. And the second parameter will be another downstream. So what happens with the values once they have been filtered. And then you can apply the same thing, the same approach as you do with mapping, filtering. You have a flat mapping, and if you remember, flat mapping helped us actually to transform something into a stream further. We've done an example a couple of lessons ago where we have changed, for example, the string to a stream of its characters. Or we could actually have a list of lists and get the values from the lists, or something like this. And these three work very similar. So let's try filtering here and say, once I have transformed them into numbers, then I want to make sure that only the even values are collected, and then I use a collector to list to put all of this into a list. So you see, I did downstream it two times. So one is the first collector, and then I have a first downstreaming, and then I have a second downstreaming. And imagine that here I could have used, for example, in some situations, another collector that had a downstream as well. So you can downstream and downstream and downstream as many times as you want. And my list of integers now should only contain the lengths that are even. So in my case, it would be this one and only this one. It's only a 6 should be in my list in this case, because it's the only string having an even length. All of this is a 3, 1, 5, 3, and again 3. So 6 is the only one in my case. But you see how nice they are. They fit together like puzzle, like pieces of a puzzle. So you simply collect them and then use a mapping, and then downstream them to a filtering, and then downstream them to a list. If you ask me, this is simply for your demonstration as an example, and for example, for an OCP 11 question, the same thing would have easier been done by simply putting them directly on the stream. So the same thing you would better in a real world scenario write like this. I will simply stream, and then you map from string to length, and then you filter from the length to be even, and then you collect to a list. So this is the way I see it better. This is the way I read it easier. If you like it more with collectors, it's the same thing, but generally I prefer to use collectors only when it's something that I can't do otherwise. In the case of such an algorithm where I need only to map and filter and then collect them into a list, like I've done in this case, I would prefer it to write it this way. And writing it this way, which I only apply a couple of intermediary operations on the stream directly and then collect them to a list, well, I find it, at least personally, I find it easier to read than using 3 downstreamed collectors, as in the case of the first result. So now if you print out the first and the second result, you will basically see the same value twice, because the two solutions do actually the same thing. So I hope you do understand what I'm explaining here, because this is not an easy subject. Actually, it's fundamental, but it's not easy. Fundamental doesn't necessarily mean easy. This is where we are starting to complicate the things here. It's not like in the beginning of our stream, in the first 20 lessons, where I was discussing about very simple things. Streams can become complicated, and they actually are one of the most complicated subjects of the OCP exam, together with, of course, threads that we will discuss in one of our future lessons. But streams can become complicated, and they can get you lost when you see a lot of parentheses and a lot of collectors and a lot of things like this. Okay, but with this I hope that I've managed to explain what downstreaming is, and we have also seen some of the mostly encountered collectors. Now let's go to the next example, example 9, and discuss another collector that is called partitioning by. Let's start with partitioning by, because grouping by, well, partitioning by is a more particular kind of grouping by. So I will start with the more particular case, which is partitioning by, and then I will go to the more general case, which is called grouping by. And I've kept the same list here. Partitioning by, as the name suggests, splits your values into two partitions. Those two partitions are they are splitted using a predicate. You know, you have to define a predicate where for some of the values, of course, the answer of the predicate will be true, and for the other values will be false. And what the predicate, what the partitioning by does, is taking the predicate, and all the values for which the predicate answered with a true will be grouped in a separate group than those for which the predicate would answer with a false. So you group them into two groups by the means of a predicate. So in my case, for example, I could say group separately the values having an odd length and the values having an even length. In this case, being that this is the single one with an even length, all the others will be in a group, and all the other the FFFFF will be in the second group. So you can do something like this on a stream by using the collectors partitioning by I was discussing, and the partitioning by gets a predicate, and the predicate in my case will be S is the string, and then I will say the length of the string should be even. So if you do something like this, if you use the predicate like this with only the partitioning by like this, the collector partitioning by with only the predicate as the parameter here, it will simply return you a map, and that's actually a map of a boolean and the list of strings in my case. So the boolean is the key because the groups will be separated into true or false, whichever the result of the predicate is. And then automatically, if you don't specify any downstream, all the values in each of the groups will be put in a list and returned. So I will in the end have as values lists of strings. So each of the strings will be grouped in a list. So if I print this map 1, let's call it map 1 because I will have some separate example as well, you will see a map with a true that will only have this element in the list and the false with all the others. So you see a false with a list with all the strings with an odd length, and the true with a list containing the only string I have here for which the length is an even number. Which is pretty easy. So it partitions, it just splits into two groups depending on a predicate. And now whatever else you can do with partitioning by, of course you can decide what happens with your values after they are partitioned. So in my case, by default, if I specify only the first parameter, so if I only specify the predicate and no downstream, then I will get a list with them as you have seen. But I can decide for partitioning by to add a comma here and a separate parameter. And the second parameter is the downstream. And I can say collectors. I don't know what I have with collections today, but it's collectors I want. Collectors, perfect. For example, to set. If I decide that instead of a list, I want a set here. And that will basically now downstream the values from the partitioning to whatever I want here. So instead of having them in a list, now I will have them in a set. So let's run the example and see how the map 2 looks like. So you see it's the same. The difference is that, of course, being a set here, you don't see the duplicate anymore, and the order is unspecified for sets, so you might see them in a different order. Like in my case, this in the list I have first the C and then the D, and then in the set they are in whatever order which is not guaranteed. You can use whatever downstream you'd like. So for example, I can go with a third map here, and I can decide that what I want to do is then to actually join the strings. So I do a joining in this case. But if I do a joining, the type of the value is of course a string, because the result of joining is no longer a list or a set. It's a simple string where the values are concatenated, as you have seen in today's lesson in one of the previous examples. So then I have a partitioning, I group them by this, and the values then will be joined. So in my case, my map 3 is what I want to print out here. In my case, instead of having a collection here, I will have a false with all the concatenated strings for which the value was false, and then I have a true with all the concatenated strings, in my case only one, for which it was like this. And I can do, again, I can do whatever I want here. I can do mapping, I can do filtering, I can downstream more if I want. So I can, for example, here instead of joining, I could have said mapping, and then from mapping, after I decide how I map them, then I will join them. So like mapping. Oh, let's keep it like this and actually create a fourth map, so you have all the values. So then I can decide, for example, instead of joining, I want to downstream to a mapping, and then the string will be transformed into, for example, its length. And then I have to add the downstream for mapping, where I decide that I do join collectors, again, joining, okay, and yeah, they are numbers, so that's why it doesn't allow me with joining here. Probably maybe I can do something like this. Okay, so I have I need to have strings to be able to concatenate. Of course, if I have numbers, joining won't allow me call the method. So I can, for example, just concatenate it here, and I just transform them, or I can use string value of if you like it better. String value of like this, and then I don't need this concatenation anymore. Okay, so that's, and then I get a string, but I will only get I will actually get now a string of the lengths concatenated in map4 if I print it out. So you see, I play with strings. I can do whatever I want. I can actually implement whichever algorithm I want, just playing with values, collecting them, and then recollecting them by downstreaming, and then recollecting them, and each time I can apply one more operation to them. So so this is actually how collectors work. They again may become difficult. So you see, now I have, instead of A, B, C, D, I have 3, 1, 5, 5 here is the 5, and then D and A. So instead of having the letters, I actually have the lengths. So it was 3, 1, and then 5, and then 3 again, and then 3 again, and then I have a 6 here. So that's where the numbers come from, because I have mapped them to the lengths and then joined them. Okay, so let me continue even more playing and discuss with you now an alternative to partitioning by, where instead of having a predicate that only allows you to split into two groups, a true and a false, you want to split them by a different rule that allows you more groups, and that's called the grouping by. The grouping by is a more general partitioning by. Instead of providing a predicate, you provide a function, and then the function can have whatever result you would like it to have. So if I paste this here, this is the example number 10, and I will simply delete all of this and keep only the first one. And instead of using partitioning by, I use the grouping by here. And with a grouping by, I can use a predicate because I can use any function. It can return actually a boolean, but I usually, when using grouping by, I usually not partition them, as if I wanted to partition them, I would have used partitioning by. In this case, let's assume I simply want to group them by their length. So that's what I actually want to do. And if I group them by their length, okay, it means that I need to have an integer here. Okay. So because integer is now the result, the key that I use to group, and in this case basically, so I get the integer and then I get the list of strings which is represent the strings for each of the lengths. So I will actually have something like 3, which has a list of whatever I have with 3 here, A, D, and then again A, and then I will have also 1, not necessarily in this order. Then I have a B, and then I have a 5 in the map, and the 5 will have a list containing only C, and then I will also have a 6 containing the Fs. That's basically what I'm doing here. because grouping by their length will create me a map where the keys are the lengths and then the values are grouped into a list by default with all the values that are grouped for that specific value. So in my case, I'm grouping the strings by their length. So the key of the map will be the length, and the value will be a list with all the strings from the stream that are respecting that length. So let's see when we print it in the console how it actually looks like our map. It will be in between curly braces, of course, because it's a map. So you see the curly braces from the map, and then you see a 1 here. And I have a 1 with the B, and then I have a 3 with A, D, and A, and I have a 5 with the C's, and I have a 6 with the F's. So basically what I was expecting, to group them by their length, because that's what I want. That's what I wanted here. And then, similar as you have done with the partitioning by, you can do basically the same thing with grouping by, like you can downstream it. You can add a new parameter here and say, okay, I don't want a list, but I actually want a set, or I want to be joining them. Collectors. Okay. So I want to be joining them, or whatever you'd like to do with them. First, of course, in this case, I cannot join them because they are numbers, but I can do like mapping, and then I can say the numbers are transformed into strings, and then I go here and add another downstream and say collectors joining. And then instead of having here a list, I will have a string. Okay, so yeah, pretty difficult it can become. So it's when going with downstreaming, it's pretty difficult. I think I will actually continue in the next lesson because we almost ended with our time for today. But I think I will actually continue with collectors as well, because I can show you more examples. The more example I show you, the more comfortable you'll be with understanding them. But then we will also have to deal with the optional class, and then with all the other methods that we didn't discuss because they were pretty related to the optional class. We still have one or more lessons to discuss about Stream API, you see, because it's a big subject, and especially with all the examples. So yeah, you see the result of the second here. I have changed them first to their length. I have grouped them by their length, and then I have changed them to, oh, they were already, sorry, I did something stupid here. I actually changed them from string to string. This mapping was not needed here. I just wanted to give you a more complicated example, but I made it stupid. What I wanted to do here was actually to say s.length or something like this. That's what I wanted to do, to change them into their length and then join them. That's why I use the value of here. So yeah, and then I would see actually the lengths here, not the strings itself themselves. Yeah, that's what I wanted to see in the beginning. But anyway, the idea is the collectors themselves, so what you learned by the collectors. Also sorting, yes, you can also do sorting with collectors. So like, for example, I think we can actually change this one. Let's see. Oh, actually, no, you actually have to do the sorting. So I had the impression that we have a sorting, but it's not a sorting. Actually, you have to sort them by the stream before and then use them. So probably you would actually do something like mapping here. Well, you caught me. I'm not actually sure if I can do the sorting inside, like inside this. No, you can do the sorting here, but I'm not sure if I ever try to do the sorting with collectors. But I will have this in mind, and I will come back with that in the next lesson, because I'm not sure enough. I had the impression we have a sorting here, but it seems that that we don't have. Do you stream every day? No, I don't actually stream every day. I do stream on Fridays and on Saturdays. On Fridays I do Spring Security now, but I'm almost I have done more than half of the stream, and the next lesson will be about OAuth 2. And on Saturdays I do streams about Java fundamentals. And generally when I say fundamentals, it's standard edition. I started with the most basics, but I will get into threads and everything that's related to OCP 11, to the OCP 11 exam. So yeah, and now collectors. Want to see a little bit. So I have accounting, filtering. Yeah, I have no sorting. So I really, if you really want to sort them, you really have to transform it to a stream and use the sorting. So you can use sorting, but we will still have to discuss about reducing and then summarizing and summing methods. We didn't touch them today. So the next stream we will discuss about this, and then we'll go forward to the optional class, and then we'll come back to the methods. You can see here some of them, they are using optional, so I have skipped them because of that. I want first to discuss what optional is, and then see these methods together with you, so that when I will use them you do understand what this optional is, in case you didn't use it before. Maybe you have, but in my streams I just prefer to consider first you didn't see the classes, and make sure that everybody understands them like this. So sorry if you already know what they are, then it's good for you, but just pretend that there might be people watching that don't know. So that's why I want to take them in a specific order in which everybody understands what I'm doing, or at least I try my best. The schedule, yes, basically I do them, it's 6 p.m. CET, Central European Time, but I do schedule all the lessons previous with one week in advance. So now after I will finish the stream, then I will actually schedule the lessons for the next Friday and Saturday, and you will find them on the channel. And if you subscribe, you will also be notified when other recorded videos, when I do other recorded videos, because sometimes I do record some videos and answer some questions and upload them to the channel. So if you want to know about all this, then my advice would be for you to subscribe. Okay, I think it's enough for today. We have seen a lot of things. Thank you very much for your questions. Thank you very much for your presence here. I hope it's useful for you again, and hope to see you also for the next lesson next Saturday. Until then, stay safe, and thank you very much, and have a great time for study.